In exercise 1 and 2, compute each matrix sum or product if it is defined. If an expression is undefined, explain why. So for 2, we need to find a plus 2b, 3c minus e, cb, e, b. So the first one is a plus 2b. That means it is equal the matrix A 2, 4, 0, minus 5, minus 1, 2, plus 2b, just we need to multiply each entry in b by 2. So this is 14, minus 10, 2, 2, minus 8, minus 6. Now we add 2 with 14, 0 plus minus 10, minus 1 plus 2, and so on. So we get the result is 16, then minus 10, then 1, then 6, minus 13, minus 4. Then we need to find 3c minus e. So 3c, we multiplied c by 3 and then we subtract minus e. But here c is 2 by 2, e is 2 by 1, so this one is not defined. Undefined because different size of matrix. Then we have CB. CB, that means we need to multiply the matrix C by the matrix B. This one is 2 by 2, this one is 2 by 3, so the multiplication is defined. So C is 1 minus 2, 2, 1, multiplied by B, 7, 1, minus 5, minus 4, 1, minus 3. So this will give us, we multiplied the first row by the first column. So this will give us the first entry. So 1 multiplied by 7 plus 2 multiplied by 1, this will give us 9. Then the first row with the second column, we will get this entry. So 1 multiplied minus 5 plus 2 multiplied by minus 4, we will get minus 13. 1 multiplied by 1 plus 2 multiplied by minus 3, we get minus 5. So now we will take the second row multiplied by the first column, then the second row by the second column, the second row by the third column. And we will get here minus 13, 6, minus 5 again. Then the last one is E, B. We know that E, it is 2 by 1, B, it is 2 by 3. So since here the inner numbers, where the number of rows of, the numbers of columns of E is different than the number of columns of B, this one is undefined. So the multiplication of EB is undefined or not defined. In the rest of this exercise set and in those to follow, you should assume that each matrix expressed is defined, that is the sizes of the matrices and vectors involved math appropriately. So we need to compute, we will do 4. Compute A minus 5i3 and 5i3a when A is given by this one. So let us find the first one, A minus 5i3. So A minus 5i3, that's mean our matrix A, 9 minus 8 minus 4 minus 1, 7, 1. Then we have 3 minus 6, 8 minus 5i3, that's mean we multiplied the identity matrix n by n identity matrix by 5. So we'll get 5, 0, 0, 0, 5, 0, 0, 0, 5. So now we subtract here, so we'll subtract each element with the corresponding element in the identity matrix, and we will get here 4 minus 1, 3, minus 8, 2, 6, then minus 4, 1, 3. Then we need also to find 5i3 multiplied by a. So that's mean 5i3 multiplied by a, that will give us 5, 0, 0, 0, 5, 0, 0, 0, 5 multiplied by the matrix A, 4 minus 8 minus 4 minus 1, 2, 1, 3, 6, 3. So this will give us, we multiply the first row with the first column, first row, second column, first row, third column, and so on. And we will get the final result here, 45 minus 5, 13, minus 40, 35, minus 30, then minus 20, 5, 40. So this is the result of multiplication 5i3 by the matrix A. In exercise 5, we need to compute the product AB in two ways. First, by the definition where AB1 and AB2 are computed separately, and then B by the row column rule for computing AB. So let us do the first one by finding AB1 is equal the matrix A minus 1, 5, 2 multiplied by the first column of B, which is 3, 2. Then we find AB2 minus 1, 5, 2, 2, 4 minus 3 multiplied by the second column minus 2, 1. So now we multiply this matrix by B1. So A multiplied by the first column, which is 3, here minus 2. So we multiply minus 1 by 3 plus 2 multiplied by minus 3. This will give us minus 7. Then 5 multiplied by 3 plus 4 multiplied by minus 2. This will give us 7. 2 multiplied by 3 plus minus 3 multiplied minus 2. This will give us 12. So this is the first column of AP. Now the second column will be A multiplied by the second column of B. So this will give us minus 1 multiplied minus 2 plus 2 multiplied by 1. This will give us 4. Then 5 multiplied by minus 2 plus 4 multiplied by 1. This one minus 6. Then 2 multiplied minus 2 plus minus 3 multiplied by 1. This one is minus 7. So AB is equal minus 7, 7, 12, 4 minus 6 minus 7. If we do this one by B, by the row column rule for computing AB, that means we take whole the matrix minus 1, 5, 2 multiplied by 2, 4 minus 3 multiplied by the matrix 3 minus 2 minus 2, 1. So then we take the first row by the first column plus then the first row by the second column, then we do the same for the second column and for the second row and the third row, and the result should be the same, which is minus 7, 7, 12, then 4 minus 6 minus 7. In 7, if a matrix A is 5 by 3 and the product AB is 5 by 7, what is the size of B? We say that A by P is equal AB. If A is 5 by 3, so this one is 5 by 3, we need to know what is B That's mean the result of AB is 5 by 7. If we multiplied A by B, the first here we have the number of row of B should be equal the number of columns of A, so this one should be 3. Then the result of multiplying this one by this one, since the inner are the same, so we'll take just the outer, so this one is 5, the second one should be here is 7. So B should be 3 by 7 matrix. Let A be the matrix 2 minus 3, 5, 1 and B the matrix 4, 3 minus 5k. What values of k, if any, will make AB is equal BA? So we want to know what is k that make AB is equal to BA. So first, if we find AB, this will be equal to minus 3, 5, 1 multiplied by 4, 3 minus 5k. This will give us here 2 multiplied by 4 plus 5 multiplied by 3. This one is 23. Then 2 multiplied by minus 5 plus 5 multiplied by k. This will give us minus 10 plus 5k. If we find this one PA, so this is 4, 3 minus 5k multiplied by 2 minus 3, 5, 1. This one 4 multiplied by 2 plus minus 5 multiplied by minus 3. This is 23 also. Now 4 multiplied by 5 plus minus 5 multiplied by 1. This will give us 4 multiplied by 5 plus minus 5 multiplied by 1. This will give us 15. We said that AB should be equal BA. That's mean 23 here, 23. This one is minus 10 plus 5k. This one is 15. So minus 5 plus 10k should be equal 15. Here we have also an element, but no need to complete this one. From here we can find what is k. So since AB is equal BA, that's mean they have the same element in the same place. So minus 10 plus 5k should be equal 15. So from here k is equal 15 plus 10 divided by 5. This is just 5. So k should be equal 5. In 10, let A is equal to minus 4 minus 3, 6, B is equal 8, 5, 4, 5, and C is equal 5, 3 minus 2, 1. Verify that AB is equal AC and yet B not equal C. So AP is equal to minus 4 minus 3, 6 multiplied by 8, 5, 4, 5. So 2 multiplied by 8 plus minus 3 multiplied by 5, this will give us 1. 2 multiplied by 4 plus minus 3 multiplied by 5, this is minus 7. Then minus 4 multiplied by 8 plus 6 multiplied by 5, this is minus 2. Minus 4 multiplied by 4 plus 6 multiplied by 5, this is 40. Then let us find what is AC. So this is 2 minus 4 minus 3, 6 multiplied by 5, 3 minus 2, 1. So this will give us 2 multiplied by 5 plus minus 3 multiplied by 3. This will give us 1. 2 multiplied by 2 multiplied by minus 2 plus minus 3 multiplied by 1. This is minus 7. Then minus 4 multiplied by 5 plus 6 multiplied by 3, this is minus 2. Minus 4 by minus 2 plus 6 by 1, this is 40. So we see that no, AB is equal AC, but B is not equal to C. In 12, let A is equal 3 minus 1 minus 6, 2. Construct a 2 by 2 matrix B such that AB is the zero matrix. Use two different non-zero columns for B. So here we have our matrix A, and we want to construct B such that AB is equal to the 0 matrix, which is this. We know that AB is equal AB1, AB2, where B1 and B2, both of them are the 0 vectors. So we find, so AB1, it is a 0 columns, AB2, it is a 0 columns. A is given, B is missing, so we use this one as a row operation. This one here we have a 0 vectors, so from here we get our A, 3 minus 1 minus 6, 2, and here we have 0, 0. So now we try to solve this one. We will swap row 1 with row 3. We will get here minus 1, 2, 0, then 3 minus 6, 0. Then if we multiply row 1 by minus 1, so we'll get row 1 is equal minus row 1. Our new matrix will be 1 minus 2, 0, then 3 minus 6, 0. Now we want this 3 to be 0, so row 2 is equal minus 3 row 1 plus row 2. This will give us minus 3 plus 3 is 0. Let us write the first row. Minus 3 plus 3 is 0. Minus 3 multiplied by minus 2 is 6. 6 minus 6, 0. And here we have this one is 0. So from here it is clear that x1 is equal to x2 and x2 is 3 is equal x2. So we may take when x2 is equal 1, p1 will be equal 2 multiplied by 1, 2, and we said x2 is equal 1. Then we need also to choose another b2. So b2, let us say when x2 is equal to, for example, so b2 will be equal 2 multiplied by 2 will be 4, and this one is 2. So from here our b is equal b1, b2 to 1, 4, 2. You can construct many vectors such that a multiplied by this vector gives you the 0 vectors, because here x2 is a free, so it is dependent on x2, the value of x2. يعني هو هنا معطلني ماتريكس A ومعطلني AB is equal to 0. فنحن على أساس نحصل على ال B نعرف إنه ال AB عبارة عن AB1 AB2. فال AB1 قيمتها 0، ال AB2 نفس الشيء قيمتها 0. بعد ما نسوي الرو اوبريشن بنلاحظ إنه ال x2 عبارة عن free variable، فنختار any value of x2 تطلع لنا ال B1، ومرة ثانية نغير قيمة ال x2 تطلع لنا ال B2 and so on. In exercise 15, concern arbitrary matrices A, B, and C for which the indicated sums and products are defined. Mark each statement true or false. Justify each answer. So 15A, if A and B are 2 by 2 with columns A1, A2, and B1, B2, respectively, then AB is equal A1, B1, A2, B2. We said this one is false. AB is equal AB1, AB2. Then B, each columns of AB is a linear combination of the columns of B using weights from the corresponding columns of A. This one, it is false. We said it is a linear combination of the columns of A using weights from the corresponding columns of B. So this one swap between A and B. Now for C, AB plus AC is equal A multiplied by B plus C. This one is true because they are in the same order, AB, then plus AC. Now D, A transpose plus B transpose is equal A plus B all transpose. This one is also true. Then E, the transpose of a product of matrices. If we, for example, if we have AB, so here it said the transpose of a product. So transpose of a product of matrices equals the product of their transpose in the same order. Is it equal A transpose, B transpose according to this? This one is false. We said it should be equal B transpose A transpose, which is, we change this one same order, it should be in reverse order. In 17, if A is equal this matrix and AB is equal also, it is given this matrix, determine the first and second columns of AB. We know that AB is equal AB1, AB2, AB3. We want to find what is the first and the second columns of B. That means we want to find B1 and B2. This one is AB1, this one is AB2. So we are looking for B1 and B2. So now if we write AB1, it is just the matrix A, 1 minus 2, minus 2, 5. We multiplied by the vector B1, which is, for example, B11, B12, sorry, B21. This will give us AB1, which is minus 1 and 6. So if we have a matrix A, we multiplied by the vector B1, the result is minus 1, 6. So we solve this by row operation, 1, minus 2, minus 2, 5, and here we have minus 1, 6, to find our B1. So after doing row operation for this matrix, we get our matrix here 1, 0, 0, 1, here 7, 4. So from here we conclude that our B1 is equal 7, 4. Similarly, we do for finding AB2. So AB2 is the matrix A, 1 minus 2, minus 2, 5. We multiplied by B, 1, 2, B2, 2, and we get this one, which is AB2, 2 minus 9. So from here we know that we can do this one by row operation, 1 minus 2, minus 2, 5, and here we have 2 minus 9. We do the same row operation, row 2 is equal to row 1 plus row 2, and row 1 is equal to row 2 plus row 1, and we get the solution of B2. So from here it is clear that B2 is equal minus 5, minus 8 and 5. So in the same way, if you want to find what is, so this is for finding, sorry, B1 and B2, the first and the second columns of the matrix B. In 18, suppose the first two columns B1 and B2 of B are equal. What can you say about the columns of AB if AB is defined and why? So if we have our matrix B is equal B1, B2 until Bn, then AB will be equal AB1, AB2 until ABn. But here it is given that if B1 is equal B2, then that's mean AB1 should be same as AB2, because this is if AB1 and same as AB2, as if B1 is equal to B2, let us see both of them is B1, BB. So let us take it as B and this one is B. Now both of them are equal, so we'll get AB, AB. So from here it is clear AB should be equal AB. So that's why here we write AB1 is equal AB2. So from here AB1 should be equal AB2. In 19, suppose the third columns of B is the same of the first two columns. So the third columns of B, let us say P3, is the sum of the first two columns, so P1 plus P2. What can you say about the third columns of A, B, and Y? So let us, if we have B is equal, for example, B1, B2, and B3, which is equal to B1 plus B2. So now AB, we know that AB is equal AB1, AB2, which is AB3. But what is AB3? AB3, it is equal A, and we know B3, it is B1 plus B2. So from here, using the properties of the matrix, so AB1, we multiplied AB1 plus, then we multiplied AB2. So from here we get AB3 is equal AB1 plus AB2. So the third column of AB is the sum of the first two columns of AB. In 21, suppose the last column of AB is entirely 0. So here we have AB is equal AB1 until the last column is 0. But B itself has no columns of zeros, so there is no column of 0 in the matrix B. What can you say about the columns of A? If we have a columns AB1, then AB2, then until 0, that means this matrix has a 0 columns. And we say that if a matrix has a 0 columns, the columns of A are linearly dependent. Because, so we said here, the columns of A is linearly dependent since A, B is a linear combination of the columns of A using weights from the corresponding columns of B, and since here we have also AB, which is the last one, AB, let us say ABN is equal to 0, but B is not equal to 0. So from here we know that AB is a linear combination of the columns of A using corresponding weights from the columns of B. Since here we have this set of vectors has 0 vectors, that means they are linearly dependent, where B is not equal to 0 but AB is equal 0. In 23, suppose CA is equal IN, the n by n identity matrix. Show that the equation AX is equal to 0 has only the trivial solution. Explain why A cannot have more columns than row. So it is given here CA is equal IN. We want to show that AX is equal to 0 has only the trivial solution. That means there is no free variable. So now if AX is equal to 0, that means if we multiplied both sides by C, we get CAX is equal to C multiplied by 0 will give us 0. But we know that CA is equal IN. So CA x is equal to 0. CA is just in x is equal to 0. So from here x should be equal to 0. So x is equal to 0, that's mean only we have the trivial solution. So ax is equal to 0, that's mean there is no free variable. i.e. every columns of A is a pivot column. And here explain why A cannot have more columns than rows, because here we need only the trivial solution and we cannot have more columns than rows, because then we will have a free variables. But since here we have ax is equal to 0 has only the trivial solution, that's mean our x should be equal to 0. So no chance for having a free variable. So that's mean either the columns is equal to the rows, or the number of rows is more than the number of columns. In 25, suppose A is an m by n matrix and there exists n by m matrix C and D, such that CA is equal in and AD is equal im. Prove that m is equal n and C is equal D. So from the first here we have CA is equal in. Also we have AD is equal im. We want to show that m is equal n. If CA is equal in, that's mean A has no free variable. The multiplication here, there is no free variable. That's mean all the variables are free variable. So the numbers of row in A should be greater than or equal the numbers of columns of A. That's mean m greater than or equal n. Similarly, if AD is equal im, that's mean the numbers of row in A is less than or equal numbers of columns of A. That's mean m is less than n. Now if we have m greater than or equal to n and in the same time m less than or equal to 1, from here we conclude that m should be equal to n. And this one is proved. Now to show that C is equal to D, we know that CAD can be written as is equal C, then we take A with D. So we know that AD is equal im, so C multiplied by im, this will give us C. Similarly, on the other hand, CAG is equal, if we take CA together and we take D here, so C multiplied by 8 is given in, then we have here D, so this one is equal D. So from here we see that CAD is equal to C is equal to D. So from here, thus C should be equal to D. In 27, we are given the vector u and the vector v. We need to compute this multiplication of vectors. So now we need to find the first one, u transpose v. That's mean first we need to transpose u. This will give us -2, 3, -4, multiplied by the vector a, b, c. This will give us -2a plus 3b minus 4c. Then the second one is V transpose U. That means we need to transpose vector V as a row multiplied by U minus 2, 3, minus 4. This will give us, take the first row, the first column, we get also minus 2A plus 3B minus 4C. Now we have U V transpose, that's mean the vector U minus 2, 3, minus 4 multiplied by the V transpose, which is A, B, C. This will give us first row with first column, first row with second column, first row with the third column. This will give us minus 2A, minus 2B, minus 2C. Similarly, the second row with first column, then with the second column, and with the third column will give us 3A, 3B, 3C, and the last one minus 4A, minus 4B, minus 4C. Now the last one is VU transpose, that's mean the vector V A, B, C multiplied by U transpose, which is minus 2, 3, minus 4. This will give us first row with the first column, first row with the second column, first row with the third column. This will give us minus 2A, 3A, minus 4A. Now we take the second row with the first column, minus 2B, then we have a 3B, then we have minus 4B. The last one is minus 2C, 3C, and minus 4C.